Welcome to the Cal Corporation's series of videos about software engineering. The topic of this video is reference variables. Before proceeding, make sure that you have already watched these other videos first. We've already seen how a type like int can be modified by adding a star symbol to describe a pointer to an int. Now, consider adding an ampersand symbol instead of the star symbol. This describes a reference to an int. A reference variable must always be initialized to some memory storage that already exists. For example, this RIA is a reference variable being initialized to a plain int variable IA. This reference variable doesn't point at IA in the way that a pointer variable would have. Instead, it becomes another name for referring to that memory location. Once a reference has been created, you cannot change which variable it is referring to, but that variable's value can be changed via the reference. A const reference variable is the same as an ordinary reference variable, except that you cannot change the target variable's value via a const reference. During reference initialization, constness can be strengthened, but it cannot be relaxed. This is the most straightforward way to pass an object as a parameter into a function. This causes your class's copy constructor to get called when the add function is being invoked, either a copy constructor that you programmed or else one that the compiler automatically provides for you. This is called passing the object by value. While inside the add function, your program is manipulating its own copy of the object, that copy being stored in the form of parameter AOBig. A disadvantage of doing this is that copy construction can be quite inefficiently slow if CRBig is a big class containing a lot of data. Passing by pointer is an alternative. Now we are faster because there is no copying. CRBig's copy constructor is not called. Instead, while inside the add function, your program now manipulates the same obig object that had been created by whatever client code is calling the function. There is only that one object in memory. The function's call is providing a pointer to that one object, and the function accesses that object by dereferencing that pointer it receives. Another advantage of passing by pointer is that we could now write our function to intentionally cause a side effect that changes the value in our client code's variable, assuming that's something we want to happen. This ability wasn't possible before with passing by value, because passing by value had been manipulating its own copy of data. But now, the change this function makes via the dereferencing of that pointer will affect the caller's obig variable. Finally, you could also have passed by reference. Passing by reference has the same advantages of passing by pointer, but without the function needing to do any dereferencing. Remember that every reference variable must be initialized to some existing storage. In this case, that reference variable is the formal parameter arobig, and it is being initialized to the client code's obig variable. A compiler temporary is memory storage. It's like a variable, except the programmer hasn't manually defined it nor given it any name. Instead, it was automatically created by the compiler because the compiler needed to momentarily store some kind of intermediate result. Usually, that's the result of some sub-expression within a larger expression that you've programmed. When this example gets compiled, the operation of adding 1 plus 2 will get translated into a machine language addition. Its result, having a data type of int, needs to be stored somewhere that the subsequent machine language multiplication can refer to. So, the compiler automatically defines a compiler temporary to store that sum of 1 plus 2. As soon as this assignment statement is finished, there will be no more need for the compiler temporary storage, so it will be automatically discarded then. Compiler temporaries exist only for the benefit of the compiler. During the time after 1 plus 2 but before 3 times 5, that compiler temporary exists, but you, the programmer, are not allowed to manipulate it. After 1 plus 2 has produced 3, you have no way to alter that 3 before it gets multiplied by 5. A const reference can refer to a compiler temporary, such as the compiler's temporary storage of this sum, but an ordinary reference cannot refer to a compiler temporary. That's because an ordinary reference would have given access to alter its target value, and you're never allowed to manipulate a compiler temporary. Type coercion is allowed to occur during const reference's initialization. The result of type coercion is kept in a compiler temporary, and the const reference variable is initialized to that compiler temporary. This example highlights the fact that the compiler temporary has its own storage, separate from the original short-typed variable. Reference initialization can also involve type coercion from a derived class to a base class. The reference will behave polymorphically.